Earth. Only Antarctica and the Arctic, both cold deserts, surpass it in sheer size. The Sahara, however, stands alone in its heat and unforgiving nature, a region that has shaped civilizations and environments for thousands of years. The desert's name, Sahara, is derived from the Arabic word Sahara, meaning desert, a simple yet profound reflection of its defining characteristic. While the sands and dunes dominate much of the region's appearance, the Sahara is far more than a sea of sand. It stretches from the Atlantic Ocean in the west to the Red Sea in the east, and from the Mediterranean Sea in the north to the semi-arid savannas in the south. This massive desert occupies nearly 1/3 of the African continent, covering parts of Algeria, Egypt, Libya, Mali, Mauritania, Niger, Sudan, and more. And while it may seem that this desert can't get any bigger, again, it's 3.5 million square miles, the Sahara is in fact growing. But how does a desert grow, especially the Earth's axial precession, which influences the monsoon patterns in North Africa? This cyclical transformation adds to the desert's mystery, making it not only a historical artifact, but also a reminder of Earth's changing climate over millennia. Let's take a look at the history of the Sahara. Over hundreds of thousands of years, the region has shifted between periods of wet, fertile landscapes and arid, barren desert. Today, the Sahara is in a dry phase, but the forces that shaped it remain active, and the desert will one day transform again. The Sahara's climate is primarily driven by long-term changes in Earth's orbit and axial tilt, a 41,000-year cycle in which the tilt of the Earth shifts some 22 degrees. That plays a central role in altering the strength of the North African monsoon. When the tilt brings more sunlight to the region, the monsoon strengthens, leading to increased rainfall and the creation of what's known as the Green Sahara. During these periods, the desert blooms into a savanna rich with vegetation. To the desert. However, as the northern ice sheets disappeared, the northern Sahara began to dry out. The southern remained wetter for a time, sustained by the monsoon, but around 4200 BCE the monsoon retreated southwards, and the Sahara entered the dry period it remains in today. But there is a remnant of this wet past. It's Lake Chad, which was once part of a much larger inland sea known as Mega Chad. That's an awesome name. During the African humid period, this massive lake covered about 135,000 square miles, making it the largest of several Saharan paleo lakes. As the Sahara dried, Mega Chad shrank into the smaller Lake Chad that we know today. Then there's the Sahara pump theory, which describes how these wet and dry cycles influence not just the land, but the plants and animals of the region. When the Sahara is green, plant and animal life thrive, spreading across the landscape. As the region reverts to desert, those species are forced to migrate north to the Atlas Mountains and south into West Africa. This region was the Scythian civilization, which thrived thousands of years ago in what is now the Central Sahara. The Scythians left behind evidence of their existence through petroglyphs and ancient rock carvings that depict scenes of life in a much different landscape than today. Following the Scythians, other cultures like the Tenarians and the Nubians made their mark on the Sahara, demonstrating the desert's long history of human settlement. Around 6000 BCE, the arrival of the Egyptian people signaled a significant shift in the region. During this time, the Sahara was lush and fertile, supporting agriculture and cattle herding. The Egyptians practiced both, benefiting from the Sahara's more hospitable environment, which was rich in plant and animal life. This fertile phase allowed for the development of complex societies that could sustain themselves in what is now one of the driest places on Earth. However, around 5,400 years ago, as the Earth's axis gradually shifted, the Sahara began its transformation into the desert we know now. Rainfall decreased, temperatures rose, and the once green The Garamantes, for example, created a sophisticated society in the Sahara, developing an early form of irrigation that allowed them to grow crops in the desert's climate. This ingenuity made them a powerful trading partner with the Roman Empire, demonstrating that life in the Sahara, though difficult, was far from impossible. In the later years, the Byzantines and Ottomans also left their mark on the region, with trade routes connecting the Sahara to the broader Mediterranean world. This history of occupation continued until the 19th century when European powers began colonizing parts of the Sahara. Following the end of World War II, many of the states here gained independence, ending centuries of foreign control. So, all of this brings us to the central question of, is the Sahara Desert growing? The short answer is yes. Over the past century, the Sahara has expanded, with many studies showing that the desert has grown by an estimated 10% since 1920, particularly into the Sahel region to the south. When we think of something growing, we tend to the lack of it. Water is essential for supporting plant life, which in turn helps stabilize soil and prevent desertification. In regions like the Sahel, the transition zone between the Sahara and the savanna, the presence of water allows vegetation to grow and act as a buffer against the encroaching desert. However, with decreasing rainfall, much of this buffer is being lost. A long-term study from the University of Maryland, published in 2018, shed light on the Sahara Desert's slow but steady expansion over the past century. By analyzing nearly 100 years of rainfall data, the researchers uncovered significant seasonal and long-term trends in the desert's growth. Their findings paint a detailed picture of how this vast desert has been encroaching further into the surrounding regions, particularly into the Sahel in the south. The study, which spanned 93 years, revealed that the most significant expansion of the Sahara occurred during the summer months. Over the duration of the study, the desert's average seasonal area in the Atlantic multi-decadal oscillation plays a key role in shifting climate patterns across the region, with changes in ocean temperatures impacting rainfall levels across North Africa. The research also touches on the role of Hadley circulation. This is a large-scale atmospheric movement that affects climate patterns in the tropics and subtropics. Deserts like the Sahara typically form in the subtropics, where the Hadley circulation forces the dry air to descend. As the climate change widens the Hadley circulation, deserts are expected to push further north into more temperate regions. However, in the case of the Sahara, there's also a southward creep into the Sahel, suggesting that additional climate cycles, such as the AMO, are driving this expansion in ways that go beyond typical northward advance. The geographical pattern of the Sahara's growth is particularly revealing. While the northern boundary of the desert has expanded northward into the Mediterranean and subtropical regions, it's the southern boundary, the transition zone known as the aforementioned Sahel, that has seen the most dramatic. Wright has proposed that human influence on the Sahara's environment goes back much further. His research suggests that humans may have played a role in transforming what was once a lush green landscape into the vast desert we know today. This theory, which only adds to the many studies that point to natural factors like changes in the Earth's orbit, opens up a new perspective on how human activity can dramatically alter ecosystems. Wright's research draws on evidence from archaeological records to make his case. He notes that around 8,000 years ago, as those early pastoralist communities began to spread across the region, their introduction of livestock significantly altered the local ecology. By comparing the spread of these human populations with changes in vegetation, specifically in scrub vegetation, which is a massive marker of shifting ecosystems, towards more arid conditions, here's where the pattern begins to form. As human populations moved westward from the Nile River Valley, they left behind areas that gradually became drier. The removal of native vegetation into the arid and semi-barren landscapes of the modern Sahara. While there's still much work to be done to fully understand the long-term impacts of these ancient practices, Wright's findings do challenge us to reconsider how human activity might have shaped the environment on a much larger scale than previously thought. The implications of this research is pretty significant. It suggests that human influence on climate and ecosystems isn't a recent phenomenon, but one that could stretch back thousands of years. The long history of environmental modification offers valuable lessons for understanding our current scale of human impact today. In particular, Wright's research does highlight the fragility of ecosystems in desert regions, with around 15% of the world's population currently living in desert or semi-desert areas. The importance of understanding how human activities affect these environments cannot be overstated. All of this just really enforces the fact that while we may have some of the answers, we probably will never truly have them all. The West African monsoon to weaken over time. The slow progression of these shifts mean that the landscape transitions gradually from a lush environment to a more arid one. However, there comes a tipping point when the degradation accelerates, resulting in a rapid transition from green to desert. The interaction of vegetation feedback and dust dynamics plays a crucial role in this process too. As rainfall decreases, plant life begins to diminish, which can lead to a feedback loop that exacerbates desertification. With less vegetation to hold soil in place, the land becomes more susceptible. This cycle of degradation can happen independently of human activities. However, it is clear that the presence of humans does complicate that natural process. During the last humid period, the Sahara was home to various hunter-gatherer communities that thrived in that verdant landscape. As the Earth's orbit shifted and rainfall diminished, these groups would have faced increasing challenges to their way of life. The need for food may have driven them to domesticate animals like cattle and goats. What it all means. The ongoing expansion of the Sahara poses significant environmental and socioeconomic challenges, creating a ripple effect that could reshape the future of the region. The transition into desertification exacerbates drought conditions, making it increasingly difficult for communities to sustain their traditional ways of life. The loss of arable land directly translates into food insecurity and dwindling resources. Economically, the stability of the region is under threat as the expansion of the desert disrupts local livelihoods. With traditional methods of food production becoming untenable, rural populations may flock to urban areas in search of opportunities. This migration can lead to overpopulation in cities, further straining limited resources and infrastructure. Moreover, the ecological implications of the Sahara's growth extend beyond human concerns. The loss of biodiversity is a pressing issue, as habitats for various plant and animal species diminish. This decline in biodiversity has cascading effects, supported a variety of plants and animals. Evidence of this verdant past has emerged from the work of researchers such as Robert Cordy from Texas A&M University and William Booz from Yale University, who have delved into the precipitation patterns of the Holocene era. During this green phase, the Sahara was characterized by a landscape dotted with lakes, rivers, and thriving vegetation, creating an environment conducive to human habitation and the development of pastoral societies. This transformation can be traced back to shifts in the Earth's orbit and the position of the Intertropical Convergence Zone. This is a significant area of tropical rainfall. As Cordy explains, the movements of the ITCZ linked to the Hadley circulation played a role in determining rainfall patterns, allowing the Sahara to flourish. By utilizing computer models and analyzing historical data, Cordy and Booz have revealed how the ITCZ migrated significantly northward during the Holocene, leading to increased rainfall in regions that are now arid. Their finding land use may hinder the region's ability to support an ecosystem similar to what existed. Additionally, Cordy emphasizes the need for a deeper understanding of how rainfall patterns could shift in response to modern climate forces, such as El Niño and La Niña events. These insights could be instrumental in predicting future weather patterns and managing the risks associated with climate variability in this region. So what's the Green Wall? Well, in response to all these regional challenges, one of the most ambitious initiatives ever conceived was launched, the Great Green Wall. The original vision for the Green Wall was straightforward: plant a massive stretch of trees 10 miles wide and 4,300 miles long across the southern border of the Sahara from Senegal to Djibouti. The idea was to create a natural barrier to stop desertification and restore the land. However, while well-intentioned, this approach faced a myriad of practical issues, like water harvesting and protecting naturally occurring trees. This shift in strategy transformed the Great Green Wall from a literal wall of trees into what many call a mosaic of sustainable land practices. The focus is on empowering farmers to manage their land in ways that promote growth, improve soil fertility, and increase water retention, all crucial for reversing the effects of desertification. The success of these methods became quickly visible. Communities that were once struggling to survive are now seeing their land coming back to life. Trees that had disappeared due to overuse are re-emerging. Soil quality is improving and the region's resilience to drought is increasing. The Great Green Wall, in this new form, is not just a fight against desertification, it's become a symbol of hope for the region, plagued by climate change, food insecurity, and economic hardship. The lessons from both the past and the present are clear. While natural cycles will continue to influence Sahara's climate, human actions can accelerate or mitigate these changes, a vital source of income for communities. The cost of achieving this wall's full potential remains significant. With an estimated total budget of $33 billion, a project must navigate a range of logistical challenges. Restoring degraded land in arid regions is no easy feat, especially when factoring the cost of maintaining newly planted vegetation. As noted by scientists working on the ground, it's very easy to plant a tree, but it's not easy to grow one. Trees must be regularly watered and protected from livestock, and these tasks can be expensive in regions where water and infrastructure is limited. Despite the challenges, though, the long-term implications of the Great Green Wall are immense. If successful, this initiative will not only restore the ecological balance of the Sahel, but also provide a blueprint for combating desertification and climate change across the world. It also has the potential to slow the loss of biodiversity, with restored ecosystems offering habitats for species that are currently under threat from the desert's expansion. Ultimately, challenges, yet many species have evolved extraordinary adaptations that allow them to survive in one of the most unforgiving environments on Earth. The vegetation of the Sahara is defined by its ability to withstand long periods of drought, extreme heat, and limited water availability. Scattered across the desert are hardy grasses, shrubs, and trees, most of which are found in highland regions, oases, and along the dry riverbeds. These plants have evolved various strategies to survive in these conditions, including deep root systems to access underground water, salt tolerance, and rapid reproductive cycles that take advantage of even brief rains. For example, many herbaceous plants in the Sahara are ephemerals, which mean they can germinate within just a few days after a rainstorm and complete their entire life cycle in less than 2 weeks. Other plants, such as halophytes, are found in saline depressions. They've developed the ability to thrive in salty soils, while species like the dome palm and acacia trees can store water for long periods, enabling them to survive the relentless heat. The Sahara's animal settlements. Historically, the Sahara supported even larger animals, including the North African elephants, lions, and addax antelope, but many of these species have been hunted to extinction or driven out of their habitats. While the last North African elephant disappeared during the Roman periods, lions were still present in the northern desert margins as late as 19th century. Today, only a few populations of once plentiful species remain in these remote regions like the Tibesti Mountains, where pygmy crocodiles and cobras may still survive in isolated drainage basins. Bird life, though, in the Sahara is surprisingly diverse, with over 300 species, including both resident and migratory birds. Raptors such as eagles and falcons soar over the desert, while ostriches, guinea fowl, and buzzards inhabit the more vegetated regions. The coastal zones too and remaining interior waterways provide vital stopover points for these migratory birds, making the Sahara an important, though sparse, ecosystem for avian life. Suggests that installing large-scale solar and wind farms in this region could do more than just provide clean energy. It could help reverse the effects of desertification, bringing rainfall, vegetation, and life back to the desert. This idea, though still theoretical, has potential to transform not only the Sahara itself, but also the surrounding regions, offering both ecological and economic benefits. Solar panels in the Sahara seem like a no-brainer. Large-scale solar farms in the Sahara could generate immense amounts of clean energy, far more than current global demand. In fact, a 2018 study suggested that if wind and solar farms covered over 3.4 million square miles of the desert, they could generate around 79 terawatts of power annually from solar alone. To put this into perspective, that amount of energy could power billions of light bulbs simultaneously and provide more energy than the world currently uses. But beyond just producing clean energy, solar panels in the Sahara could have far-reaching, positive environmental effects. According to some simulations,